That means actually 60 minutes divided by 5. That means lambda is equal to 12, because lambda is always expressed as per hour arrival rate. You will write that as 60 by 5. Every 5 minutes one customer, means 12 will arrive in 1 hour. That is given by 60 by 5. This is lambda. Then similarly we have to give about the mu or service rate, which is every 3 minutes. So per hour it should be 60 by 3, which is given by 20. That means 20 customers are per hour are being served. Once this is done, we will go to solve, because we require lambda and mu always in hourly rate. In any problem, if they are given in minutes or seconds or any other measure, we should convert that into hourly rate. Even in sometimes if they give per 8-hour shift, that should be also converted into hourly rate. And after converting into hourly rate, we need to substitute in the formula. Here first thing was average waiting time in queue. Average waiting time in queue is given by WQ. So that is given by lambda divided by mu into mu minus lambda. Lambda value we know 12 per hour, mu value we know 20 per hour. So 12 by 20 into 20 minus 28, 12. You will get that. That is equal to 12 by 20 into 8. That is 160. So if we want the value in minutes, waiting time in the queue, we should multiply that with 12 by 160 into 60, which may give us approximately 5 minutes. Anyhow, we can compute that LC. And similarly, average number of customers waiting in the system, in the queue. Okay, we will find out how many customers are there in the queue, or which we also call that as length of the queue. Okay. This length of the queue is given by LQ. We represent usually by LQ, which is given by lambda square by mu into mu minus lambda. So lambda is given by 12 square, lambda square divided by mu is 20 into 20 minus 12, which is given by 144 divided by 20 into 8, 160. So this also, if you want it, you can convert that into multiplying with 60, you can find out. Okay, length of the queue here means it is less than one customer that is waiting in the queue. It should not be calculated in minutes. Anyhow, it is because 160 by 160 will give us 1. That means on an average only less than one customer is waiting. And what is the probability that the counter is ideal? That means what is the probability that there are no customers in the queue at all? That is given by P0 is equal to 1 minus lambda by mu is equal to 1 minus 12 by 20. That is given by 1 minus 0.6. That means there is a probability that the counter may be ideal to the extent of 0.4 or 0.4 probability. And average waiting time in the system, that is given by WS, which is nothing but average waiting time in the queue plus the time spent at the service station. This put together we call that as WS, which is given by 1 divided by mu minus lambda, that is 1 divided by 20 minus 12, that is 1 by 8 is equal to 0.125. We want to know in minutes, it is 0.125 into 60 is equal to 7.5 minutes. So actually 3 minutes was the service time, that means 4.5 minutes the customer might be waiting in the queue, because waiting time in system is nothing but waiting time in queue as well as service time. And then we'll see utilization factor, that means to what extent it has been used. Actually it is given by lambda by mu. Lambda by mu is equal to, that is 12 by mu is 20, that is 0.6. It is known as utilization factor. What it means is 60% of the time the counter is being engaged, and the rest of the time the counter might be idle. That is what is given. The probability of the counter being idle 0.40 we got. 1 minus 0.6 is 0.4. Probability that there are at least 2 customers in the queue. So that means what is the probability, or how much of time that there may be 2 customers in the queue waiting for the service, that we have to calculate. That is given by lambda to the power of lambda by mu to the power of n plus 1. So this n is nothing but 2 customers, that is 12 by 20 whole to the power of 2 plus 1, that means 3, or cube, 12 by 20 cube, which is given by 0.6 to the power of 3, which is given by 0.216. That means there is 0.216 customers will be there. 0.216 probability is there that at least there are 2 customers in the queue.